All right, good afternoon, third graders. You are going to be working on math with me this afternoon as well. You'll be working in your workbook, following along with me as I'm going through the problems together. You should be writing them all down in your workbook together. When I ask you to pause, please do so that you can work through them on your own, and then you're welcome to come back to the video to check your answers. So good luck to you. Please make sure that you remember any of the questions that you have or ask your guest teacher. They should be able to answer a few of them for you, if not all. But make sure that you've jotted them down so that I know that what you have for questions. Let's get started. Okay, so we're going to start with page 419, lesson 11.9. We're looking at something called equivalent fractions. So the equivalent fractions is where you have two fractions, and they're equivalent if they name the same portion of a whole. So when you remember, when we had our fraction circles, you had a whole, and then you put 4 blues on top, and that can also make a whole. So 4 blues, 4 fourths was the same as a whole. These two are equivalent fractions. They name the same pieces of the whole that you have. So if you're looking at, it says use your halves, fourths, sixteenths strips. We're not going to worry about those because we've already looked at those pieces, but they are in your workbook if you want them to answer the following questions. I think a lot of you will be able to answer them without those. It says if you put your half strips over the fourth strips, if you take a look right here, this picture, you can see that 2 fourths are the same as a half. So you see how they line up right here. This lines up and this lines up right over here. They're the exact same amount. So at the bottom here, it asks you to complete the equation. And it's saying, complete these two equations. How many fourths equal a half? 2 fourths equal a half. So I have 2 fourths equal a half over here. So they equal the same amount because of how it shows in the picture. 2 fourths is the same distance from here to here as it is with 1/2. That's called an equivalent fraction. Think of the word equivalent. Equivalent has the word equal almost inside of it. That's how I remember that equivalent fractions are equal fractions. So if I take a look at the next one, it says how many eighths are in 1/2. So if I think of 1/8, and I think of a picture, I'm stuck here, okay, back to my eighths. If I think of eighths, so I have a bar, and I'm going to split it into eighths. Each one of those pieces is a 1/8 piece. And I have to think of, well, what is a half? Well, if I have 1, 2, 3, 4, 5, 6, 7, 8 pieces all together, half of that is going to be split in half right down here. So you see this is a half. How many sections of the eighths do I have? I have 1/8 plus 1/8 plus 1/8 plus 1/8. That gives me actually 4/8. And if I remember that 4 is half of 8, that's going to be the same as a half. So if I look over here, so I'm looking, I just figured out that 4/8 is 1/2. So I'm going to do, I have how many eighths are in a half? 4, which then means I have 4/8 equal 1/2. So I have 4 over 8 equals a half. How many sixteenths in a half? Well, I can think about how much is half of 16. 8. 8 sixteenths. 8 sixteenths. So I'm always thinking, what is half of the 16? When I get down here, it says how many eighths are in 1/4. So that again, I might need to make myself a picture. So if I grab myself a picture over here, I'm going to know 1/4. There's 1/4. Those are fourths. And if I break it up into eighths, you'll notice that I just half each one of those. So how many eighths do you see in 1/4? 2. So I have 2 eighths in 1/4, 2 eighths in 1/4, 2 eighths in 1/4. How many sixteenths in a fourth? If I go back to my picture, I'm going to half each one of these again, because that's 2, 4, 6, 8, 10, 12, 14, 16. How many do I have in here? 1, 2, 3, 4. So I have how many 16ths in a 4? Fourth, 4, 4, and 4. Alright, so if you look at the back, it's looking at thirds, sixths, and 12ths. If this is getting a little bit uncomfortable for you and you're not moving as fast as I am and you're needing some extra support, I would suggest that you ask to get your fraction circles to take a look and have your sixth and put your sixth on top of your thirds and put your 12s on top of your thirds so that you have a better understanding of what it looks like. So I would suggest you get that out if you need it. Some of you may not, some of you may. I'm going to go through and do the answers for this, and why don't you pause and give it a try. Alright, here are the answers that I got. How many sixths are in a third? 2, so 2 and 2. How many 12ths in 1/3? 4, 4, 4. Here I got 4 sixths and 2/3 and 8 12ths and 2/3. I'm not going to worry about number 10 right now. So now, as you can see, I'm asked to show that 2 7ths is equal to 6 21sts. And it says by factoring each part of the second model. So right here, you're going to see that there are 2 already of 7 pieces. And here there's that same 2 of 7 pieces, but they want me to make it into 21 pieces. Okay, so you can see here that I've factored each one of the boxes, each 7 boxes, into 3 more pieces, which now gives me 27 spots altogether. And now you can see I have 1/7, 1/7 here, 1/7 here, which gives me 2 7ths altogether. Here I have 1 21st, 1 21st, 1 21st, all the way through, which gives me 6 21st. So that works because I have something that's called a multiplier in the box. Are the fractions equivalent? So if I look down at the bottom of this page, if I end up multiplying each of these parts by the same number, I'm going to get this equivalent fraction. If one of these two, if these are different from each other, then these 2 fractions are not equivalent of each other. So I have to think, what's 2 times something gets me 6? Well, 2 times 3 gets me up to 6. Does 7 times 3 get me 21, or does something else get me 21? Well, in this case, 3 does get me set 21. 7 times 3 does equal 21, which means they are equivalent. This one here, I have 1/5 to 4 25ths. So here I have 1 multiplied by something to get 4. Well, what can I multiply by 1 to get to 4? The only thing I can do is 4. And then here, 5 times something gets me 25, or 25 minus 5 gets me 5. Because these are different, these are not equivalent fractions. This is not the same amount as this, because I'm not multiplying by the exact same number. Go ahead and give number 4, 5, 6, and 7 a try. Here are my answers. Number 4, they're multiplied by the exact same number 2, so I have yes. Number 5, multiplied by 3, both of them, so I get yes. They are equivalent. And then 6, 4 times 10 is 40, 9 times 10 is 90, so yes, they're equivalent, because it's 10 and 10, but this one, 6 and 7, is a no. Okay, so I skipped the bottom of that page, numbers 8, 9, and 10. I'm not going to worry about because I'm going to still focus on that factoring a fraction. So go to page 427 in your workbook. All right, so I'm going to read the top. Please follow along with me. Equivalent fractions show the same amount, but they're divided into different unit fractions. Factoring a fraction gives us an equivalent fraction with more unit fractions, but the unit fractions are smaller. So here's what that's saying. If I'm taking a look at this space right here, I'm noticing that there are 3 spots. And so that this fraction shows 2/3. But over here, if I factor each one of those sections to an additional 5 spots, now I've got smaller pieces. So I'm sharing with more people. But I have more pieces to share, they're just smaller. So when I'm looking at my factoring, I'm saying 2/3 multiply the numerator and the denominator by 5. So 2 times 5 is 10, and 3 times 5 is 15. So my new factor should be that there are 10 that are blue and 15 altogether. Down here, they're telling me to come up with it on my own. Here I have 4 sections, and 3 of them are colored in. So I just move that fraction right over here to my equation, and I multiply each of them by 3. 3 times 3 is 9, and 4 times 3 is 12. So I should see that this picture shows 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded in, 10, 11, 12 altogether. Go ahead and do the rest of the page. See if you can do it without looking ahead in the video. All right, here are my answers. I have 3/4 times 3, a numerator denominator, give me 9/12. Then I got 1/2 times 7s, gives me 7/14. 4/6 times 2 is 8/12. And 4/8 times 3 is 12/24. Check your answer and then move on. All right, so looking on page 428, number 6, it just kind of condenses it a little bit for me, just in a little bit smaller format. Looking at 1/2 here, multiplying or breaking each half up into 5 additional pieces. So 1 times 5 is 5, 2 times 5 is 10. And then I'm going to do the same thing the rest of the page. So why don't you do number 7, 8, 9, and then we'll come back together and I'll do 10 through to 17 again. So what you should have accomplished in this time is making sure that your multiplier here, they're the exact same on the numerator and the denominator. It should not be 2 different numbers, otherwise this is not going to be equivalent to this side. So if I look at this next one here, I have 3's, 2 times 3 is 6, 3 times 3 is 9, and then 2's. 3 times 2 is 6, 5 times 2 is 10. So what they've been asking me to do is find that multiplier. So if I go down here, I'm looking at, well, what multiplies by 5 to get up to 15? So I can count on my fingers, 5, 10, 15. That's 3. I'm going to verify that 8 times 3 is 24, but it should be exactly that. Moving along on this side, I need to multiply 4 times something to get me 28, and 9 times something to get me 63. And again, this is where if I don't know one of these things, this one doesn't just pop right out at me. I might need to add my 4, 8, 12, 16, 20, 24, 28. I might need to lay out my 4's times table just to make sure, and then count how many that is. 1, 2, 3, 4, 5, 6, 7. 7's here, and it should be 7 here, but again, I can check. 9, 18, 27, 27, 28, 29, 30, 31, 32, 33, 34, 35, 32, 36, excuse me, 38, 28. So just because I got myself confused, 1, 2, 3, 4, 5, 6, 7, and that is confirmed. The bottom, it's asking you to think about the missing number as well as the multiplier. So you're going to start by finding the multiplier here using this 9 here, 10 times 3. So I know that this is 3, moving it down here as well, and then knowing that it's, what is 8 times 3 gives me 24. So I'm finding that first one, 5 times something gives me 40. That's 8. I'm going to continue 8 up here, and I get 16. Go ahead and finish that, and I'll bring up the answers. Here are the answers I got. Times by 7, 35 over 63. Times by 5's 20 over 35. Times by 5 again, 25 over 30. Times by 8, 24 over 32. We have one more piece to do, and then you'll be all done for today.